Okay, so these notes are over going from vertex form to standard form with quadratics. We're going to be working with quadratics for the next couple of weeks. So I have a quadratic in vertex form, which is f of x equals x minus 4 squared plus 9. What's really neat about vertex form is you're able to look at the equation and pull the vertex without doing any work. So your vertex, to get the x of your vertex, you always go inside the parentheses and take the opposite of that number. So this number in the parentheses is negative 4, which means the x of my vertex is going to be a positive 4. Then to get the y of your vertex, it's always just the number hanging out at the end. So it's a positive 9. You don't take the opposite of it or anything. It's just whatever that number is. Okay, so always go inside the parentheses, take the opposite. That's your x. Outside of the parentheses is your y. So this quadratic has a vertex of 4, 9. Now, your first step is to FOIL. And what we're going to FOIL is this x minus 4 squared, because that's not just x squared minus 16, which a lot of people think. You have to actually work out x minus 4 times x minus 4. Okay, so we're going to FOIL that out, double distribute, box method, whatever you're comfortable with. So you will go x times x is x squared, x times negative 4 is negative 4x, negative 4 times x is negative 4x, negative 4 times negative 4 is positive 16. Okay, now I'm going to combine like terms within the parentheses. So I have x squared minus 8x plus 16. And I keep putting it in parentheses because if we had an a outside of the parentheses, which right now we don't, so it's considered a 1. But if there was a number in front of the x minus 4 squared, we would then need to distribute a. So that's what step 2 is. So actually we can just skip that step for this problem because a is just 1. And so now our last step is to combine like terms. So we end up with f of x equals x squared minus 8x plus 25. So if I were to put this equation in the calculator and this equation in the calculator, they would graph the exact same graph. Okay, my next example, I have f of x equals 1/2 times x minus 7 squared plus 3. So real quick, I can find the vertex. So the vertex is positive 7, 3. So I went in the parentheses, took the opposite, so it's positive 7, and then the 3 is just hanging out. So to put this into standard form, I am going to have to work out x minus 7 squared. So I have 1/2 times x minus 7 times x minus 7 plus 3. So I'm going to have to FOIL. So I get x squared minus 7x minus 7x plus 49. Okay, combine like terms in there. So I have 1/2 times x squared minus 14x plus 49 plus 3. So this problem actually has that extra step that we didn't have in the last problem. So my next step is I have to distribute my 1/2, and it's going to go to the x squared, to the negative 14x, and to the 49, but not go to the 3. So 1/2 times x squared is 1/2 x squared. 1/2 times negative 4x is negative 7x. And 1/2 times 49 is a positive 49 halves. And then plus 3. To add 49 halves and 3, I have to get a common denominator. So I put 3 over 1. So a good common denominator is 2. So I'm going to change 3 over 1 to be 6 over 2. And now I can combine like terms. So I get that my quadratic in standard form is f of x equals 1/2 x squared minus 7x plus 55 halves. Okay. And my last example, I have f of x equals negative 4 times x minus 1/2 squared plus 4. So really quick, just to be in the practice, the vertex is positive 1/2, positive 4. so now to put this into standard form, I'm going to FOIL out the x minus 1/2 squared. So I have negative 4 times x minus 1/2 times x minus 1/2 plus 4. So multiplying this out, x times x is x squared. X times negative 1/2 is negative 1/2 x. Negative 1/2 times x is negative 1/2 x. And negative 1/2 times negative 1/2 is a positive 1/4. And that's being multiplied to negative 4 and add 4. I'm going to combine like terms within my parentheses. So I have negative 4 times x squared minus x plus 1/4 plus 4. Okay, now I need to distribute my negative 4. So it's going to go to all three of these terms. So negative 4 times x squared is negative 4x squared. Negative 4 times negative x is positive 4x. And negative 4 times 1/4 is negative 4. I'm sorry, no. Just made a mistake. That is a negative 1. And then my last step is plus 4. So I end up with a quadratic f of x equals negative 4x squared plus 4x plus 3. So there's my standard form of that quadratic. And that is it for going from vertex form to standard form for quadratics.